So here we're looking at different kinds of resistors and how they can be useful. We've got three kinds you need to know about. There's the thermistor, the light-dependent resistor, and the diode. Diode is obviously not really a resistor by itself, but it does have some resistance, and it's got some useful properties that can be used for different things in circuits. Ultimately, these can be used to make decision-making things in circuits. Anyway, thermistor is just a thermal resistor, and it changes its resistance depending on temperature. Normally, when something gets hotter, it gets more resistance, but this is made from special materials so that whenever it heats up, what actually happens is the resistance decreases. So we see this increasing temperature and decreasing resistance. The LDR, which we can recognize with these two little arrows, shows that it's absorbing light. So that kind of tells you it's absorbing light. This little thing just tells you it's a thermistor. And in a similar kind of way, as the light intensity increases, the resistance decreases. Don't know why I've scored that out. The thing with a diode is, if you look at this, you can see it kind of looks like an arrow, and that tells you that it only permits current in one direction. Okay, which is why I represent it with a graph with positive and negative values. So what we get is, if we get a voltage in, let's say, we'll call this the wrong direction, okay, then we don't get any current. It's effectively got infinite resistance. And then what we get is, at a fairly small level of voltage, what we suddenly get is a resistance dramatically decreases. Now this is only for a very small range. There's a limit to this, so that if you put a high enough voltage across it, you're just going to break the diode. Okay, so diodes are usually connected in series with a resistor, so the current doesn't get too high in them and break them. Okay, unfortunately, it's not particularly interesting when they do break; it just stops working. So let's look at how this can be maybe useful in a circuit. So we've got a certain source of EMF here, so we'll just say 12 volts because I like to use that. And what we're going to have here is, we're going to have a circuit which controls a heater. Okay, so we're going to have a thermistor right here. So as it gets warmer, its resistance decreases. So what's going to happen is, let's say that let's just say at this certain temperature, so let's say at 10 degrees Celsius, okay, this has got a resistance of, I don't know, 50 ohms. And this is a fixed resistor, so this has also got a resistance of 50 ohms. So what we can say is, at 10 degrees Celsius, these will both have an equal EMF across them. So, PD across them. So that would be 6 volts, and then this would be 6 volts at 10 degrees Celsius. But let's say temperature increases, so let's say temperature increases to 30 degrees Celsius. Well, that means its resistance decreases. So it's going to go down to some smaller values. So I don't know, let's just say down to 10 ohms. So now it's at 10 ohms, so this can't be at 6, nor will this be at 6. If we remember our ratios, then this means that 1/6 of the potential difference will be through this. So now we've got 2 volts, because remember, that's 10 out of the total 60. And that means, of course, then this is going to have 10 volts across it. So when the temperature increases, what we get is a lower voltage out of this. And that's really useful, because what we could do is we could have a heater connected on this. So if we had our heater connected this way, so here symbol looks like this, very much like a resistor, as you're used to. So that means when the temperature increases, we get a lower voltage in the heater. So the heater is going to reduce the amount of heat it gives. So we can achieve similar things with an LDR. For example, connect the LDR with maybe a light bulb or something. So when light intensity increases, the light bulb itself gets dimmer. It's an example of negative feedback, which you probably would be familiar with from biology. For example, whenever your body temperature increases, what do? You start to sweat, you change your behavior, and so something that produces a rise creates an effect which makes it come back down again, and that's kind of what we're doing here. It's not very usual to see questions like this, but I think it gives a better understanding about, well, because I remember doing this at GCSE and they just taught us these three, and what do we care? No, just know them. Okay, what do we care? I can also talk a little bit about diodes, okay, because they impose conditions upon the circuit. Ultimately, diodes can be used to, in more elaborate circuits to make decisions. But really, all you guys need to know is it only permits current in one direction. So that if something changes up here, well, then it won't let current happen if current goes the other way. So, if you remember stuff about alternating current, so let's say we have an AC, okay, and we represent that using this little wave, so 12 volts AC. And we connect a diode like this. Well, that means that what we'd actually see, so this signal would go in like that, all right, so you get your AC. But because this only lets current in one direction, what we would see is something like this. It doesn't permit this other direction to the current. Now, why that's useful, you don't need to know until A level, but what it effectively allows us to do is turn an alternating current into a direct current, which is in one direction. We need to do a little bit more, because obviously we don't want this lumpy current with blanks in between, but we don't need to study that until A level.